Welcome to the presentation on cable termination and splicing. In this presentation, I'm going to skim over some of the things that we've already been working on throughout the semester. So I'll move rather quickly at certain points along the way. What are we going to be talking about? How we terminate splice cables or cross connects, but we've been doing that for a while, so nothing new there really. We have the color code schemes. You'll find that fiber has a very similar color code scheme to that of our copper-based cabling. And as we finish up every chapter presentation, we'll talk a little bit about documenting the work. With that, move to the next slide. Up to date, we've talked about terminating cables in the work area, the jacks, creating patch cables, putting plugs on each end, terminating our distribution cables, the 25 pair lab as an example. But one of the things we really haven't talked about is the demarcation point, or as we refer to it in the field as demarc. This is the point where the outside provider brings their cabling into the facility and we terminate that cable, or actually they terminate the cable, and then we cross-connect to that cable for our inside plant needs. The external provider is responsible for the cable coming into the facility and up to the point of demarcation. At that point, the responsibility for the cabling transitions to that of the business or campus. So this is, again, just commonly referred to as the demarc point. It's a very important point to check for problems. If you get reports of network problems, in particular talking about voice networks, that would be a prime location to go check and verify the symptom. And the reason being is what you would do is disconnect the inside plant cabling and connect directly to the outside plant, thus verifying if the circuit is working from the outside provider. And again, we've talked about terminating cables in the equipment room, telecom closets, as well as the work areas. So with that, read through the bullet points and then move to the next slide. To date, we've discussed different organizations that have either been standard setting bodies or those identifying codes that we must adhere to, such as the National Electric Code. And again, most of it's been regarding standards used in the field. However, we have not talked about the FCC, the Federal Communications Commission, in particular Rule 68. Rule 68 was developed to ensure the safety of our telephone network. The stipulations in Rule 68 call for a number of standards to be adhered to by manufacturers. The idea is that we could potentially have manufacturers creating equipment that could do damage to equipment and components on the network, and thus actually providing a security risk to the country. So AT&T pushed hard to have a number of standards put in place, and the FCC agreed, and Rule 68 was implemented. Thus, the manufacturers manufacturing the equipment that would connect to the public switch telephone network today have to adhere to a number of manufacturing standards to ensure that their equipment would not do harm to the network. Pretty important step. I've always felt that AT&T developed a lot of good standards over the years. They built a pretty robust network, and they wanted to ensure that hardware connected to the network would not do damage to any of the electronics located down the path that calls would take. So, FCC steps in, creates Rule 68, manufacturers must adhere to it. However, at the same time, the Rule 68 doesn't state that the equipment necessarily even has to work. It just has to not do damage to the network. With that, please read through the bullet points and move to the next slide. When I think of small systems, I'm looking at maybe a small business that has a number of business lines basically that go directly to work areas. However, there are small systems out there that I used to refer to as key systems, usually running up to maybe 15 extensions on the key system. The advantage was you'd still only have several business lines coming in, but the system would allow you to patch calls through to various extensions, thus serving a number of work areas but minimizing the number of reoccurring costs on a monthly basis by keeping the number of business lines down to a minimum. Key systems. Now, there was a kind of a mid-level system out there that was good for mid-sized businesses, maybe in the neighborhood of 50 extensions. And again, what you do is just not to have that many business lines coming in. In that case, maybe you'd have 6 to 10 business lines coming in that would serve about 50 extensions. Again, reducing your recurring monthly costs. Certainly you have that upfront cost for the electronics of the mid-size system. On the larger end, that's when we start hearing about PBX systems, private branch exchanges. Those systems can go from the mid-size level right up to thousands of extensions. In fact, I think it was the test beds for Sprint that I dealt with years ago, and I had to call somebody there, and I was actually given a 5-digit extension after calling the main number. So then you're talking into the thousands, tens of thousands of extensions on a system. So systems can vary greatly in size, and the number of terminations that you may have with them can vary greatly as well. With that, read through the bullet points and move to the next slide. On this slide, we have images of devices referred to as NIDs, Network Interface Devices. Should look familiar. If you've ever taken a look around your home, you probably have 1 to 2 of these attached to the outside of your house. If you live in an apartment complex, you're going to have a much larger type device, but this is set up for 1, 2, maybe 4 lines coming in. And note, there are screw terminals on there, and there's also 2 sections to the enclosure. One that's set aside for the telco staff to work with. The other side is for customers. The side with the telco wiring in is typically either locked or screwed down with special security screws to keep customers out of that. That's their side of it. This NID forms the demarcation point, and essentially the customers will bring their wiring into the customer section of the NID. Again, this serves as the demarc point. If you haven't seen one of these, take a look around your home and see if you can spot one. Cable companies use them as well as the telephone companies. With that, go ahead and move to the next slide. In larger systems, we have pretty sizable distribution fields, and we'll use a number of different style punch-down blocks. You've been using the 66 style and 110 style on a regular basis now, but note there's also Bix and Krone. There's a 210 style out there, and recently I referred to the new 110D style connection blocks used in the field. Each type may have a different style punch-down tool, but essentially they're all doing the same kind of action. They're punching down a cable. We're using IDC style connections. Hopefully you know what that is. If not, it's insulation displacement connectors, and that's a common theme throughout the telecom industry. So we'll see different styles, but essentially very, very similar methodologies used in terminating cables around our facilities. Also, I've talked about the backboards. Hopefully you remember the specifications on those. 3/4 inch plywood, sanded one side, painted with fire retardant gray paint, and mounted very, very securely against the wall. With that, please read through the bullet points and move to the next slide. The image on the screen shows a NID that has 2 major components, one being the connecting blocks, the terminations themselves. The other one is the protector. What do the protectors do? Hopefully you have some idea at this point. We're protecting against some kind of energy spike. We're doing surge suppression from typically going to be a large voltage spike coming into the system. Lightning hit our telecommunications outside plant cabling. This helps dissipate that energy. You can see the reference to ground on the top. Of course, this is going to be part of our grounding and bonding system. And a very important part, that this is grounded so we can dissipate that energy into our ground path rather than to our electronics connected to our internal wiring distribution. With that, go to the next slide. In this image you have another illustration of a NID. You'll see the protectors on the left, the termination block to the right of that. Then the telco would cross-connect over to the termination blocks you see on the right, which forms the actual demarc point. You see the reference to the word POP. Well, that's an acronym that stands for point of presence. That's all it is, but it is used heavily out in the field. The black circular shaped donut at the top is basically just a spool to allow for cable management, so you can run cables down the termination blocks. Also note the oval shaped devices that go with the top of the terminations near the top of the 66 block on the right. Those I've ran into in the field, typically they're red and they denote special circuits. The idea basically is to keep your hands off of it. It's a special communications circuit that if you put test equipment on, you could disrupt the data stream, thus causing a problem with the system. Typically they're high cap circuits, high capacity circuits. First thing that comes to mind is like a T1 circuit, which is a 1.544 megabit bit stream system that has 24 channels concurrently running over it, and it can be voice channels, it can be data channels that can be combined to create a larger data pipe. High cap circuits can be any kind of data service special circuit, and the idea is just to keep your hands off of it and leave it alone. Otherwise you could be disrupting some kind of service. With that, move to the next slide. Please read through the bullet points and move to the next slide. Please read through the bullet points and then click the speaker icon at the bottom of the screen.
Never mind on the speaker icon, that link is no longer active.
In figure 6-6, we show the demarc point on the left-hand side, again, POP, point of presence, physical location or co-location of the equipment. In this case, it's the wiring coming in from the central office. Again, you see the hinge lid to the left, and then we have cross connects running over to, you'll see the reference to IDF, an intermediary distribution frame terminal block that then has multi-pair cables coming out the bottom heading to an IDF or a telecom closet. On the far right, you'll see where we have cross connects running over to a termination block that then has station cables or horizontal cabling running out to the jacks located in a work area. Please move to the next slide.
With that, I'll close out this YouTube video, and please go to the next one and start that one up.